Hello YouTube and preppers, this is the Comms Prepper with a video about repeaters and how they work. Before I get into actual repeaters, I want to clarify some terms that I'm going to be discussing during this video, and that's the difference between channel and frequency. We hear a lot of people use these two terms interchangeably, and really they're not. The term channel is a label or a designator. I have here an example for this slide of a generic radio programming software screenshot. And you'll see highlighted in yellow down the left-hand side are the channels 1 through 16. But to the right of each one of those channels, there's a box for the transmit frequency and the receive frequency. So channel 1 actually has two frequencies associated with it, and you're going to find this in all your modern radios, that there's a transmit and a receive frequency associated with each channel. And that's critical when we're talking about programming radios to talk on repeaters, because you have to have a different transmit frequency and a different receive frequency on the same channel. And here again is an example on the next slide where I've configured channel 1 for 146.100 for transmit and 146.700 for receive. It's the same channel, channel 1, but it has two different frequencies associated with it. So when you're not pushing the button to transmit, the radio by default is listening for 146.700 signals. But when you hit the transmit button, it's transmitting out on 146.100. And two walkie-talkies sitting next to each other wouldn't be able to talk to each other because they're talking and listening on two different frequencies. And that's where the repeater comes in. What we're accustomed to with FRS, GMRS, and MERS radios is when the transmit frequency matches the receive frequency. And I gave an example of this below in channel 9 of this software program, where channel 9 has the same transmit and the same receive frequency. So again, I just want to clarify that the term channel and frequency are not interchangeable. There's two different meanings. On this slide here, I have a block diagram of a typical single channel walkie-talkie radio. And it's not a complete block diagram, just to give you an idea of the mechanics, what's taken place. So I have a single channel radio with a transmit side set for 146.100 and a receive side set for 146.700. And you'll notice above this block is a little relay, the transmit/receive or TR relay, and that switches signaling between the transmitter and the receiver. So in a normal default condition, when you turn your radio on and you're not transmitting, that relay in default is set to the receive side of the radio, and the green lightning bolts represent radio energy coming into the antenna, down through the circuitry, and getting routed over to the receiver so you can hear it on your speaker. When you want to transmit, you pick up your radio and you hit the transmit button on the side. And what that does is it activates your microphone and throws that relay over to the transmit position. And now the circuitry is routing the transmitter out to the antenna to radiate your signal out. And it also deactivates the receiver. So it's either transmitting or receiving. It's not doing both. So again, in default and receive mode, the relay is over in the receive position, and when you transmit, it throws that relay over into the transmit position. So now let's meet a repeater. I have a little image of that radio we just shown down in the lower left-hand corner. But what makes up a repeater? Well, on the left-hand side, I have an antenna, which comes down on coax, and that coax split, and it goes into these tuned cavities, a thing called a duplexer. And the duplexer separates the receive frequency from the transmit frequency and then routes that separately to the repeater. So you have the receiver, a repeater controller, and then the transmitter. And what you should notice here is the transmit frequency in the walkie-talkie is actually the receive frequency of the repeater. And the transmit frequency of the repeater is the receive frequency of the walkie-talkie. So how does this work now? So here's the repeater in receive mode. It's actually receive and transmit at the same time, but we're going to walk through the flow of how this works. So you have a walkie-talkie, it's transmitting on 146.100. That signal strikes the antenna, comes down the coax, and the first thing that happens is it hits that T. Now these cavities, highlighted in yellow and green, think of these as the coin sorting machine at your grocery store. The yellow ones are adjusted or tuned only to pass the receive frequency or only to accept pennies, and everything else is rejected. So all frequencies except for 146, 100, or pennies are going to pass through the yellow duplexer cavities to the receiver. Once that signal gets over to the receiver, the audio is passed to the repeater controller, your signal, and then that is passed down to the transmitter to be retransmitted back out. And just like the cavities up top are tuned for only the received frequency, or pennies when you're thinking of it as a coin sorting machine, the transmitter cavities, highlighted in green, are tuned to only pass the transmit frequency 146, 700, or pass nickels if you use a coin sorting analogy. So that transmit signal goes out through those cavities up to the T, and because the receiver cavities, the yellow ones, aren't tuned for the transmit frequency, that signal doesn't go back into the receiver, it goes out to the antenna. And all this happens simultaneously. So received frequency comes in, it comes down, gets routed through its portion of the duplexer cavities to the receiver, to the repeater controller, to the transmitter, out through the transmitter side of the duplexer cavities, up to the antenna, and out to all the walkie-talkies. So this is a circle, this is a cycle, and it all happens at the exact same time. So here's another slide, another example. So we have Jack and Jill. Jack's on the left-hand side, Jill's on the right-hand side, and they can't talk to each other because there's a mountain in the way. So you put a repeater in a good spot. And what happens is Jack transmits up on 146, 100. It's received at the repeater on 146, 100. The repeater routes that down to 146, 700 and transmits that out to the received frequency on Jill's radio, which is 146, 700, and you have communications. The same thing happens in reverse. Jill transmits up on 146, 100. It gets to the repeater. The repeater passes that signal, that audio, down to the transmitter. The transmitter of the repeater transmits that back out on 146, 700, and it's received by Jack. So what are the advantages to having a repeater? Why would you want one to begin with? So on this slide, I have an example of a couple of mountains in the way, and in the top center there's a mountain with a repeater on it. But without that repeater, in this example, the walkie-talkie in the lower right-hand corner would try to communicate with all the other corners, and it can't do it. So the bottom example, there's a mountain in the way. In the middle example, trying to talk to the top left-hand corner, the distance is too far. So there's not enough radio power, there's not enough wattage. So it can't communicate to that radio. And then the top right-hand corner, there's another mountain in the way. But if you strategically locate your repeater in an area where all your users can see the repeater, then they don't have to see each other, and they can have communications. So in this example, the radio in the lower right-hand corner can see the repeater. It's transmitting up to the repeater, and the repeater's repeating that signal for him, and it goes out to all the other handhelds or users on that network. So that's how repeaters work in a very basic explanation, and to give you an idea of how they can apply and how you can utilize them as part of your communications plan, as part of your preps. And again, as always, thank you for watching my videos and subscribing to my channel. This has been the Comms Prepper.